And then Kent from CyberMDX is going to tell you a little bit about their company before we go ahead and get started with Robin. Take it away, Kent.
All right, thanks, Megan. Hey, I'm Kent Conwell from CyberMDX. We are the sponsors of this next event, this riveting event with Robin. As a quick review, we are one of the leaders in security for protecting the Biomed and IOMC type devices. As you know, IoT brought a whole new level of capabilities for organizations in the healthcare field to connect and reach more environments more quickly, but it also brought a lot of risk. We found that 80% of medical devices run on outdated or out-of-date patches for their particular systems, and these offer perfect vehicles for bad actors to get inside. In fact, at the recent HIMSS show, we actually demonstrated the hacking of an infusion pump live there at the event. Just last month, the Hive ransomware started to rear its ugly head and actually got the Memorial system in Ohio and West Virginia. 3 of their hospitals had to go to paper charts. All of their IT staff was working 24-hour days trying to get the system up and running. CyberMDX is a healthcare security suite that helps you minimize this problem. Our portfolio includes categorized, protects connected medical devices, ensuring the resiliency as well as patient safety and privacy. With CyberMDX solutions, you guys can act more swiftly in situations where minutes make all the difference. At CyberMDX, we take the art of security and turn it into science. Thank you. Enjoy the session with Robin. I appreciate your attention. Have a great day. See you at Happy Hour.
Thank you, Kent.
You're welcome.
Robin, you are all set to take it away.
Cool. I got the same one already.
Perfect.
I have an echo for a while. For those who don't know me, name is Robert Fott. I'm part of the local association. I got an associate's degree from Biomed from Johnson County. Master's degree was online from Intercontinental University. And I've been doing Biomed since the mid-1990s. I took 5 years off to be a computer systems analyst. If you want my address, email address, go for that. If you end up ever having questions about cybersecurity and such, I don't mind answering questions. Text, send me an email and I'll answer you as soon as I get it or finally read it. Network data security, you get a good definition of it. There's 3 parts to it: availability, integrity, and privacy. Has to be available. Data it means is useless if you can't get to it. Integrity, make sure people don't tamper with it. Privacy, only those who should see it do see it. Most of IT is very good with dealing with integrity, privacy, and they keep forgetting availability. At least as far as I can tell within hospitals. Medical devices, basic devices for network security. Firewalls, everybody's just heard about firewalls, they've been around forever. It's basically the idea is to keep people out. Intrusion detection, intrusion prevention. Seeing if someone gets in, catch them after they do. Try and stop them from getting in. Technically, a firewall is part of intrusion prevention. Our sponsor is basically an intrusion detection system. See what's there, keep track of it, make sure they're not doing anything they're not supposed to. Something starts looking odd, it's obviously an intrusion. Time to alert someone. Other things you're going to find out with more and more multiple hospitals, you're going to have VPN routers creating through normal internet a tunnel between the 2 spots. Backups are part of a lot of this. I have had arguments with IT. They like going these constant online backups. If it's online, it's available for it to be hacked at. Software-wise, antivirus, malware removal are generally the softwares you'll have on computers and servers. Certifications. Anybody who's helped deal with setting up wireless on devices, you might have heard of certifications. It is literally just a software code referencing a site to verify that this is what it says it is. They get interesting too. Network certifications. This has been on my mind a lot because Microsoft just recently bought someone out and we had to change all our network certifications at the hospital I work at. I work at China Mission. IT was going to just roll it all out. You can't just roll it out into the patient monitoring. So we had to go out and physically, manually reassociate to another network and install it. It was fun. There are generally two types. One is referencing a root certification or higher certification. Root certificated agents tend to be Microsoft or Google, Yahoo. Number of logins that will have you log in using those credentials or using that higher certification. Another one is called self-certification. I am who I am because I say I am. If you want to believe that. Oddly enough, all root certifications are self-certifications. Microsoft is who they are because they say they are, and we believe them. Maybe saying this a bit ahead of time. Anything that's software can be copied, hacked, whatever. So these are able to be forged, and a lot of effort gets put into trying to stop that. Encryption. Gotta watch out for that. The idea of taking plain text, converting it into something that looks like nonsense, and then pulling it back out. This is a simple example of how you can do an encryption. An example that came up at the top of my head for someone a long time ago to explain it. Not knowing how many people still remember their digital electronics class, the logic table for it, the example of merging a key with data and getting the data back out. Of course, that is easily hacked, very simple, but it gives you an idea what it's done. This would be a private key setup. One key. The keys are getting longer and longer because computers have been getting faster and faster and easier to hack. Common key size now is 256 bytes. Unfortunately, they already know that is able to be hacked by a good, strong networking server in under a week today. They've been trying to delay that by making the mathematics of the encryption harder and harder. But even that is about to get extended. Pretty soon your standard's going to be 512 and 1K encryption key lengths. We'll go back a little later. Private key, there's only one key to encrypt and decrypt. If a hacker gets a hold of the key, the methods are public domain. They will be able to undo what you sent. And the sender must share that key with the receiver, making that transaction a vulnerability point. A lot of the Wi-Fi access that you log into, when you put in your passcode, an encryption key gets exchanged. And at that exchange, you can capture that, you get the key, and you can decrypt all the transmission from there forward. Public key encryption uses two keys, one to encrypt, one to decrypt. It is one directional. Just because you know one key doesn't mean you know the other, and doesn't help you undo the process or redo it. This is becoming more and more popular. The public side key is usually attached to a certification at some point. So if I have a IT cert for a network, that cert would have the public domain key in it. The encrypting private key would be kept secret. Actually, so they're the other way around. The encrypting key is public, the decrypting key is private. Encryption styles that are popular so far, and again, these things are changing. Least strength to most strength. Actually, it stops here. These are two algorithms using encrypting. And they tend to be increasing key length as it goes. WEP is a fairly short key. If you know you have a network that uses WEP encryption, you can hack it with a PC nowadays in less than a day if you have the stuff to do it. WPA was the next process. Again, hackable by a person at home with a standard PC nowadays. You get WPA2, WPA2 Enterprise. The Enterprise is used the longest key so far and is what people are moving to, have already moved to. There should be some more after that. They're not common. So I'm not doing about it. Even among these, you get to choose which algorithm you use for encrypting and decrypting. AES, TKIP. And they're just two different mathematical formulas. No reason to know them if you want to know them. I don't even know. They weren't even in my master's degree. I think if you're curious, wants to look them up. Forgot. Hash is like encrypting something without being decrypted. And all you do is get garbage, but it's the same garbage. That where I stopped banging onto it. The password you put in for Windows for logging in is converted into a hash right there on your computer, essentially halfway through the encryption. It gets sent to the server and compared in hash form to what your password was over there. So your password on the server is stored in hash form. If I hack that server, theoretically, I cannot find out your password. But I can find that hash, which is, unfortunately, often just as good. Windows XP, if you remember Windows XP, when you typed in your password, you got a bunch of asterisks, which was Windows saying, I can't display this character. Its vulnerability was if you copied those asterisks before the person actually hit enter to put in their password, you could paste those into that password point and log in as them. After Windows XP, they stopped allowing that to happen. Corrected. Simplest form, instead of using an XOR function, use more function. Just as an example of how hash works. That's of course not how they do it. On the flip side of all that is how people try and break into this stuff. Social engineering, convincing the user to give you the information they want. That is still the most vulnerable way to get in there. All this social media that we have, I have accounts on it. I virtually never get on it except to see what might be posted, because I know that's the place to do the research to figure out what someone's keys, someone's passwords might be. Someone's a big Chiefs fan who's the current quarterback of the Chiefs. Yeah, try it. I'm not a sports fan, so I couldn't even tell you who they are, who the players are today.
Yeah, so kind of on that note, I bet you I have 50 different passwords with all the different software places I have to get into. And I made a mistake using the same password once, and after I was on, I had changed mine already, but they were able to hack into whatever business I was ordering cards for. And then, of course, they threatened me, sent me emails. My IT department, somebody got on some other site around, and they were able to hack that. He goes, "You never use the same password for anything." I said, "Yeah, I usually don't. I have a few times, but I will never again." You know?
Yes, I have a series of very different passwords.
Yeah.
I'll give you an example of some of my passwords later, but I got my own method of creating a password. I'll even tell you how to create a really tough password violating all the rules on passwords, i.e. never use your name, never use your birth date, never use your social security number. I'll violate all three and give you a really difficult password to break. So anyway, currently they talk about phishing, i.e. trying to convince you to give your stuff up through electronics means. Realize all this is very old. All these concepts are very old. Back when computers were first coming out, the idea of social engineering was used to hack the telephone networks. Get on, dial up the operator, convince them that you're a service person in the field and you need access to the long distance trunk. And they just kick you over without any charge, and you make a long distance call. This is all old ideas. Spear phishing, aiming for a specific group or a special group of people, usually done through advertising. Biomeds, send us something with a link to service material, manuals and such. Have the link go somewhere else and strip information out. Whaling, high profile targets. I don't know who comes up with these names, but they're fun sometimes. Smishing, text phishing, which is hitting very popular again because Congress just recently passed some legislation to try and make text spam harder to do. Phishing, old-fashioned phone call to try and get information. Hi, I'm your customers. I need this information to verify your account. I'm sorry, I work with you and you don't know what my account number is. Q-rishing, the QR codes. I don't ever scan a QR code because you don't know what it really says. Was it an ND Expo or an AMI conference? I was actually one where they were demonstrating how easy it was to generate a QR code that routed you through a server to the site you wanted to go. And in the process, stripped out all your contact information out of your phone. And they built the QR code right there.
Yeah.
Yes, yes.
Scan the QR code to your server, you guys.
Search engine phishing. I actually had this one happen to me. When Google first came out to this area with their fiber optics, I was having an issue of some sort. Did a quick search for their service number, called it up, and got some company that's definitely not Google. They wanted to send me up to their level 2 technician for a fee. Hold on, I'm asking you basic questions here. What do you mean sending me up for a fee? I might just keep them on the phone for an hour. But all this is based in some form, getting a hold of someone and pretending you are someone you are not. Sometimes through an email, sometimes through attachment. Few hacks are really going through into the system without going through someone. Attacking the system directly is the hardest way to do it. Not impossible, but the hardest. I'll have to remember to rearrange things at some point. I should have pointed out ahead of time. One of the securities one should always think of in networking, including medical devices, is if a hacker can physically get a hold of the device, you've lost. Most hacks I've seen for IV pumps and such require directly accessing the device. Not really going to the network and hack, literally going up to the device, hooking into it, and getting into it while the device is sitting right there with you with your computer.
You said in the on it's all remote.
Remote is making it easy, but remote is still the hardest way to do it. Medical equipment usually does not talk in a manner that you can hack with it. It literally sends data packets, not programs, not web pages, but straight up this data packet. So hacking is harder. How do you get it to try and run a program you want it to that you have to send to it in that fashion? Now, at some point, they're going to start doing software updates to these things through the network. That becomes hackable. But updating a drug library, okay, I can change the drug library, but I can't get the device to act the way I want it to.
Yeah, but if you change the drug library, you choose concentrations where they wouldn't know what they were.
Exactly. That's the danger there. But most of the hacks I saw, they attacked directly.
That's what tends to be wrong one. It's not. It's 100% wireless.
Yeah.
Never touch the pump. Uses 5 mLs. Works fine. They go into it all through remote. Next one that says it and uses 5 mLs and uses 50 mLs. You can watch it right there.
Yeah.
McAfee did. That was the first one I saw. I'm like, okay, this could happen. All the rest of them, like, oh, we plug it in, we took it apart, we changed the chip, and then you're not.
No.
Yeah.
The one I saw was they went and literally hacked the operating system of the pump, but they had to be direct connection to it to do it.
Look up Ebron and McAfee.
Right. And what they did is hacked the drug library, and that is the danger part right there. It's also partially why I don't like remote data centers for hospitals. Corporate has all our data servers. There is no copy at the local site. It's all. Okay, remember the first slide about availability? Do a denial of service attack on admin. been corporate. Not emissions trouble.
We had, years ago, off of Highway 40, they had a data line, and we had two service providers,
Both taken down.
buried in the same place. So we hit it, they took them both out. No one did the work to find out that, hey, these two are physically together. Yeah.
Olathe had that same problem, and they finally corrected it, sending data out in both directions. They also did the same thing with power. They were relying on one power connection, and they lost it for some reason. So and actually, in their case, it's two different power companies, or was. So it goes for more than just IT. I think what they took out for Olathe was a connection down to Miami County. And so they decided to do connections on opposite sides of the hospital and two different complete routes down. Hardware for hacking. Again, the idea of if someone physically gets to the device you've lost, keyloggers are one of the easiest ways to hack someone's computer. Literally, your keyboard connects USB, put a little capture device in there. It'll capture every key they do. The computer never sees it. It looks like it's just connected straight to the keyboard, and everything they type in is caught. Most people don't see where their keyboard's plugged into. It's plugged into the back. I actually at one point ordered a software keylogger to test something and wasn't paying attention, cooked it up to my computer, and my antivirus wiped out the keylogger. So a software keylogger, the antivirus will see. I would think it would see a hardware keylogger too, but I'm not sure because the hardware keylogger would have to have memory. At some point we had fun rolling one of those. From keylogger, the attacker would then just spend a bunch of time searching straight down and finding the most common combination of two words, and that should be the password or the user ID and the password. I get creative with my user ID, was nothing really bad, really hard to figure out for me. My most common user ID is Batman Sidekick. I'm a imposter. What do you get? I have another one that's Hood. Okay. So that's get someone's password just straight from them keying it in. Data loggers are like key loggers, but it would be in the network and it would be just catching everyone's stuff passing through. And again, that's a physical thing. I would walk up to a network switch, hopefully pick a port that I know is what's referred to as a trunk, where all the data goes through, usually one switch going up to another, put a device in between to capture all the data going through. I was expecting actually to do the network fundamentals before I did this, but do note that almost all network devices are a store and forward. Your data goes from your computer to a switch, the switch stores it, and when the port it's supposed to send it out to is available, it sends it on. Store, forward. And same thing with the router, all the way through. Technically, anything stored there can be copied off. So, I like pointing out that IT, where so much of their insecurities are coming from. A lot of it is their equipment. Ways people hack if they don't physically get a hold of your devices, educated guesses for passwords. This is where most social media comes from. Most people use family member names, hobbies, sports activities, anything like that. Research a person, get on social media, look at everything they got. What's their pet's name? Like I have research it, Facebook, Instagram, Twitter, YouTube, whatever they get on. Whatever they have, they got. I don't keep up with YouTube things. Do they still allow you to post your own videos on there?
Yeah,
Okay, that's what I thought. So, yeah, catch some. It's also a great way to figure out when. Yeah. It also will tell you when someone's not going to be home, so you can go in and attack their network directly.
I like the people that put on Facebook, oh, I'm down in the Caribbean, and then someone goes robs their house.
Yeah. Come on, people. You just announced it to the world. What do you expect? We are our own worst enemy in security in this manner. And we really are. The one encrypting attack at a lake, someone opened a PDF that was actually an exe file and took out all the shared data. My first big argument with an IT department. Other ways to do some of this. Availability was first requirement in data security. Denial service attacks. Constantly go and request login at the same place over and over again, so fast no one else can get in. They figured out how to block that by not only allowing so many requests from a single IP address or MAC address, so they went to a distributed denial service attack, where a whole bunch of computers do this at once. This occasionally happens naturally. You get a very popular concert. They just finally put tickets online at midnight, whatever day, and the computer crashes 2 seconds later because so many people went to try and order tickets and took down the network of the being able to get tickets. Physical attacks, gaining access, as I said, the hacker can physically get to the network, you've lost. There's no way you're going to stop them from getting information from you. Doing things, various hacking styles. Man in the middle. The QR code idea that I mentioned earlier, where it will directly direct you through someone else's server to them to the page you are. The server you're being directed through will stay there and capture everything you do. That's a man in the middle attack, which is, like I said, don't trust QR codes. Well, guess what? Everybody's using them. Yes, I can't tell you what that QR code sends me to. Though, if you use a QR reader on your iPhone, you can have it tell you what it says before going. Yes, do that. Always check your links. In case people don't realize how network naming goes, the last 2 segments in the thing, the .com, .org, whatever, and that's changed a whole bunch of things. One of them now .family. And the thing just before that, separated by the slash. That last one after the last slash is the important one. That's where you're going. The last 3 are not right, you're going somewhere else. Very famous example, whitehouse.gov and whitehouse.com. One was the web page for the White House. The other one was the web page for a brawl. Was. Yes,
I'm using. .org.com. People commonly mix it up. Be careful what you type in. Be careful what it says.
On the link you see is the actual link you're going to. It could say anything.
Yes,
Unless you actually hover over and look at the link.
right. Yeah, don't. I set these things up on our webpage ourselves. Just because it's highlighted saying that's what the link is. Look down here and say what you're, generally it's the lower left-hand side of the screen as you're looking at it, will highlight what that link is actually going to. And I might have it on our webpage is the picture, or I write down the link and make sure they match. Common thing, if they say it's going to be one thing and it says it's another, don't trust it. Even if it looks like it's good, don't trust it. Paranoia is a wonderful thing on the internet. And if those QR codes, if it does go to a third party, it really is amazing what the phone will let them take. Full contact information. Literally, the example they showed, they literally downloaded their full address book, complete.
But a virtual private network will not interface between the QR code and give you an extra level of security?
No,
It won't?
no. If that QR code says to go to this proxy server,
Yeah.
then you have a VPN to that proxy server.
As soon as the VPN is open, they don't have to have a handshake to go back to
No,
pull any information.
what this is doing is you are asking directly to go to that place.
Okay. It's not like handing an RWAP packet through the network, and that's the concise
Right.
allocation of information and nothing more.
What a VPN does is I will connect to this computer.
Yeah.
Our encryption between those two computers is now going to be, our data between is going to be encrypted as if we have no one else on the network to it. And it stays that way until you break the connection. But if you say, I'm going to this proxy server, then to that whatever server, that your connection to that proxy server is the tunnel. The next one is not, and the proxy server unencrypts it. So they see it wide open. Because that's where you said you wanted the tunnel to. Mm-hmm. Yeah, it's amazing. You can think you did it the right way and still. So it's, and it's detail. It is fine detail. Even the beginning of that web address, you usually get a www dot whatever, whatever. If it says test dot or home dot or, and you think you should be going to www, you're going to another server. It might not be theirs anymore. Chances are you weren't the right one because the next one is Amazon or whatever. But you might not be on the server you think you are. For Amazon, okay, they can have dozens of servers. It will not be www. That's just their front end server. But trying to think of an example. Before they ran out of IP addresses, you could bypass the front end server and go directly to the back servers. So you could go directly to a test server or a shop server or whatever like that. And a hacker could hack that specific one without attacking the front end. So for a while I was careful on that. Now there's so few IP addresses, you're forced to go to that front end server. All the rest of them are translated. So unless you have their router, you will always get that front end. That is also mentioned in that network fundamentals.
Ransomware is all the rage nowadays. Getting the system encrypted after payment of the key. I always love these people that pay the ransom. Okay, right to print free money for wherever that money's going to. I've only heard of one case where the ransom was gotten back by the federal government. There might have been others. The federal government's finally getting hard on these things, trying to block transfer of money. Very hard to do. But once you get attacked that way, even if they pay to have the data encrypted, the IT department now has a lot of work to do. Best thing they can do is, assuming they're given a key to decrypt all this stuff, is take the whole system completely offline, decrypt everything, and now they got to change all their settings or be hacked again by the same people, by a third party that the people sold the data, the method of hacking to. Yeah. If you get hacked this way, I don't see how paying gets you out of any trouble whatsoever. Important things that happen at that point. If you're encrypted, restore from a backup. Backups, everybody's in these online backups. But if you have an online backup, you have a vulnerability for that being encrypted too. No one is doing online backups, I know. I tried to get a Lather to do that, and they wouldn't. They wouldn't give me the time. So the good thing about online backups is they're always up to date. They're always instantaneous right now. The good thing about offline backups, they're offline. They can't be gotten to. You physically go there and put it back in place. So, but you will lose whatever data was created between the time to backup and the time to that. Brute force attacks. This is the hard way hackers do things. This is where they literally will try and break an encryption by going through and randomly trying every possible combination. It takes a lot of work and a lot of time. The shorter the encryption key, the easier that is to have. I wasn't paying attention. I just got past the slide. It'll be here a little later. But a 256-bit encryption would be like a password from there to there. If you do anything shorter, you're using a smaller amount of that key. It's just as soon as they're checked because it's fast, the easiest thing to hack. So long passwords. Most hackers are not skilled enough to do this directly. They use lots of scripts. The person who does that is referred to as script kiddie. And the fun thing is that's easy to get a hold of. I can even tell you what to download. If you want to have fun trying it. You have a lot of learning curve to do it, but if you want to, go for it. Most of those hackings, brute force hackings, start with common words, combination of common words, small sentences, which is why just putting in a word is not a good idea. Protections, physical separations. As I said earlier, VLAN is not a secure thing.
A VLAN is, it all goes through the same switch. Have one port marked as a trunk and all the VLANs go together and you can leave it on. Security, no. And a lot of IT departments will say, oh, it's secure, we have it on a separate VLAN. Not really. Oh, here's that example. Large encryption keys, including large passwords. Note, common encryption size. 256-bit is the common size. How long a password do you need to use the whole encryption? You can put in longer, but that's the minimum length to use the whole possibilities of encryption. Ensuring your software is up to date, patches. For computers, that is true. For medical equipment, OEMs don't come out with security patches that often. But even if they do, they really need to be heavily tested. Something that a lot of management and IT do not understand is the amount of testing you really should do on any update you do to make sure you know what you're doing going out. Don't take a whole system down. Not bad. Any questions? And this is my joke here. The old man, so life in reverse and everything is 42. Comes out of the Hitchhiker's Guide to the Galaxy. And what is then the question is, what is 6 times 10? It shows you something fundamentally wrong with the universe.